Hello physics class, it's Mr. Ng and I have a short tutorial on Coulomb's law. To go through this tutorial, you're going to need a scientific calculator. I know that some of you might not have scientific calculators at home. So here I have Desmos, right? If you just go into a window and you type in Desmos scientific calculator, it takes you to this module. And I've been playing around with it. It's a pretty darn good module, and that's the one we're going to use. Okay, let's hop into this tutorial on Coulomb's law. Here's our very first question. A negative charge of -2 coulombs, that's huge, by the way. Like, usually the numbers that you'll get will be like to the -9 or 10 coulombs. This thing is a really, really strong charge. And a +3 coulombs, these are really strong charges, are separated by 80 meters. That's not going to do anything. Like, it's got to be way farther. What is the force between these two charges? Okay, so this is like a huge amount of force. And let's see, number one, we got to use our equation. And our equation's right here. The force of an electric charge is equal to K times Q1, the first charge, times Q2, the second charge, divided by the distance squared, right? Part 2, let's find our variables. I'm lucky in that I could write right on top of it, but for you, you might need to make a little list of your variables. I have a Q1, I have a Q2, right? These coulombs are charges. And then these 80 meters, that's going to be a distance. It's not r squared yet, right? We're going to have to square that thing. Okay, and finally, we just have to plug in and solve. Pretty darn easy. So that's step 3. So that means my electric force is equal to K. Ooh, I should tell you what K is. K is equal to 8.99 times 10 to the 9th Newton meters squared Coulomb squared. I'm going to ignore the units till the very end. So here, the electric force is equal to 8.99 times 10 to the 9 times -2. That's my Q1, right? Q1 is -2 times 3 divided by my r squared. My r is 80 divided by 80 squared. Okay? This thing is going to be really, really big, and it's going to be negative. Because it's going to be a negative number, we know that it's attracted to each other. When it's positive, it repels. But let's plug it in. So I'm going to plug it into Desmos. 8.99 times 10 to the 9th, right? I like doing an equal to, so it just kind of knows, and I like doing answer. It makes it nice and neat. Times -2 times 3, right? Let's equal that. And then let's take that answer, and then let's divide it by parentheses 80 squared, close parentheses, equal to. And there we go. That's our answer. It's really big. I told you it was going to be big. This is -8,000. Well, no, it's way more than 8428125 newtons. So this is 8 million newtons. This thing is really, really strong. And notice that because it's negative, we know that this is attracting. All right, these two charges are being pulled towards each other. When it's positive, that means it's the same charge, and then they're going to repel. Good? Okay, let's do sample number 2. Sample number 2 says a negative charge of -0.005 coulombs is attracted with a force of 9 newtons and is 10 meters away. What is the magnitude of the second charge? So this switches it up a little bit. It wants Q2, right? So again, number 1, our equation, which is the electric force, is equal to K times Q1 times Q2 divided by r squared. And then number 2, let's find our variables. So this is a Q1. This is our electric force. 10 meters is our r. So what is the second charge? So here, let's plug in. But then instead of solving, let's plug in and find Q2. All right, and then it will solve. So here, Fe is equal to Q1 times Q2 times K divided by R squared. And this is the variable I want to isolate. So this is going to be pretty easy. I'm going to multiply both sides by R2. This is FE times R2. That makes it equal to K, Q1, Q2. Now I'm going to divide both sides by KQ1, KQ1. So I end up with Q2 is equal to FE R squared times R squared divided by KQ1, right? Ooh, now we plug in. 4, solve. So I know that my second charge, Q2, is equal to my electric force, it's 9 newtons, times my R squared, it's right here, R squared, which is going to be 10 squared, divided by my K. K is 8.9, 9 times 10 to the 9, times Q1, and my Q1 is negative 0.0005 coulombs. Okay, all I got to do is plug in. So let's do that. So 9 times 10 squared, 9 times, I'm going to do parentheses, 10 squared, close parentheses, good. So that's my numerator. And then my bottom part is going to be 8.99 times 10 to the 9th, right? Equal to that answer times negative 0.0005. Good. So now I just need this number, right? Copy. And I'm going to divide it by this number. Copy. There you go. So I got negative 2 times 10 to the 4th. Q2 is equal to negative 2 times 10 to the negative 4th coulombs. Good. So what did I do? Very similarly, I had the equation, I found the variables, and then this part with the algebra, like, you just got to get used to that algebra. So plug in, go nice and slow, look at what I did in Desmos, and try to make sure that you can repeat those steps on your own calculator. Okay, last example. Two negative charges are both negative 3 coulombs. Man, these things are really, really strong. And they push each other apart with a force of 19 newtons. How far apart are these two charges? Well, they got to be really far apart because 3 coulombs each is really, really strong. So let's start. Let's start with the equation where the electric force is equal to K times Q1 times Q2 divided by R squared, right? Number 2, let's identify our variables. Okay, so this is Q1 and Q2, right? That's what the question says. This is our electric force, and it wants to know R, right? It doesn't know R. How far apart are the two? What is the R? So let's plug in and rearrange. And we want to solve for R2 now, or just R, right? We want to solve for the radius, for the distance. So I'm going to plug in. I know that the electric force is equal to K times Q1 times Q2 divided by R squared, right? That means R squared is equal to K times Q1 times Q2 divided by the electric force. That means R, the distance, must be the square root of K times Q1 times Q2 divided by the electric force. Ooh. So that's a lot of plugging in. Let's plug it in. Our radius is going to be the square root, really big number, 8.99 times 10 to the 9th times negative 3 times negative 3 divided by our electric force, which is 19.2 newtons. Oh, I don't need that newtons yet because I'll put that in at the very end. Right. Okay. So Let's put it into Desmos. I'm going to try my best to kind of put it all in as one, and I will show you how to do that. So here, let's clear all. I'm going to do square root, and I'm going to put it in parentheses. My numerator, I'm going to put it in parentheses. Numerator, 8. You know, I'm going to do two parentheses. 8.99 times 10 to the 9th, and I'm going to close that parentheses. Okay. And then I'm going to multiply that by -3 times -3. Oops, I got to make this kind of big. There we go. And then I'm going to close that parentheses. And then I'm going to divide that, all of it, by 19.2. Done. Okay, let's find it. Oh, it's right here. That means our answer is equal to, oops. Oh, it's really far away. 64915.8. So, when we talk about sig figs, it's only to 2, so I could write it to 3. So that means 651.2 meters. Oops, little m. All right, so 65,000 meters. It's really far away because a Coulomb is a really large number. Okay, so I'm not too worried about you guys figuring out the equation. You could find the equation, you could find the variables. But I think for this assignment, you might need to play around with your scientific calculator and mess with it until you could get the same answers that I can get. Thank you very much for watching.